Morning, Algebra 2 students. We're here today to talk about 11.6, geometric sequences and series. Now, in a geometric sequence or series, the focus is, instead of arithmetic where you are adding consistently over and over to get the next term, instead you are multiplying over and over to get the next term. So in this first example here, if I multiply each previous term by 3, I get the next term. So this is geometric. And something we're going to learn about on the next page is a common ratio R. The common ratio in this case, what you multiply to get to the next term, is 3. In this next example, if you add 3 each time, you get the next term, but that's not multiplying. So there's no number you can multiply 1 times to get 4 and then 4 times to get 7, the same number. So this is not geometric. Finally, in this last one, if I multiply by a half, same as dividing by 2, if I multiply by a half each time, I get the next one. Or if I cut it in half, half of 4 is 2, half of 2 is 1, half of 1 is 1 half, half of a half is a fourth. So this is geometric. And its common ratio is 1/2. All right, so let's talk about that common ratio. It's represented by R, and the way you find it is you take the second term divided by the first term, and that is your common ratio. Now, that could be happening with any 2 consecutive terms, and we said before, one way to write that, a general term is a sub n, any particular term, and the term before it would be a sub n minus 1. So if this is 5, n was 5, then n minus 1 would be 4. Get the idea? So that is important. And then I'm going to need more room, so I'm going to erase this. And the rule for the nth term a sub n is equal to a sub 1 times the common ratio to the n minus 1 power. This is actually a much easier setup than the arithmetic ones. Now let's do an example here. 5, 20, 80. 320. So if that's my example, the way I'm going to find a sub n is first I need to know what R is. R is going to be, for example, 20, the second term, divided by the first term, or 4. So when I go and fill this in, a sub n is equal to the first term, 5, times the common ratio 4 to the n minus 1 power, and that is the entire problem. Let's try another one. What about this one? 13.5, 9, 6, 4. Now, in this one, I could find my common ratio by taking 9 and divide by 13.5, but that's a little bit cumbersome. especially compared to, for example, say I do 4 and 6. Much easier to reduce to 2/3. And there's your common ratio. So our a sub n rule is going to be the first term, 13.5, times the common ratio 2/3 to the n minus 1 power. And there is the rule for the nth term. Now there's one other type of problem that we might run into when we're trying to find our rule for the nth term. And that would be when you're given an example like this one. A sub 4 is 32 and r is 2. If we start out with that information, we're going to use the a sub 4. So 4 is our n. We don't know a sub 1. We need to find it. So a sub n, or a sub 4, is 32. It equals the first term, which we don't know, times r, which, r we do know. R is 2. To the n, in this case, n is 4, minus 1. So 32 equals a sub 1 times 2 to the 4 minus 1, 3. 32 equals a sub 1 times 2 to the third is 8. And when you divide both sides by 8, a sub 1 ends up as 4. Now I can go ahead and fill in a sub n equals a sub 1, 4, times r, 2, to the n minus 1 power. And there you have it. Now, I want to do one more, and this one is asking you not just to find the rule for the nth term, but also to find a sub 6, for example. So we're going to find the rule and then find a sub 6. Here's our original. -1, 3, -9, 27. Notice there's some negatives and some positives. Well, I'm going to plug the values in for a sub n. -1 is our first value, a sub 1. r, 3 divided by -1 would be -3 to the n minus 1. So I used a sub 1. 3 divided by -1 is -3 to the n minus 1 power. Now that I have that, a sub 6, so that's one answer. A sub 6, because we're asked to find the sixth term, not just do this, equals -1 times -3 to the 6 minus 1 power. Or to the 5th power. Now, -3 to the 5th power is going to be -243. And when you multiply here, -1 times -243 is positive 243. And that's your a sub 6. All right. Last couple examples. We're going to find the summation of the sequence, which we know is the series. So a geometric series is found by S sub n equals a sub 1 times, now this is a little complicated, 1 minus r to the n over 1 minus r. And that's how it's set up. Now let's do a simple example of that. And we're going to find S sub 8. So, first term, a sub 1, times 1 minus, now the common ratio, 2 divided by 1 would be 2. So that's your common ratio, second term divided by first term. So 2 to the n, 8. 8 is our n in this case, over 1 minus r, 2. Now it turns out if you raise 2 to the 8th power, you get 256. So s sub 8, 1 times, now eventually I'm going to get rid of that 1 because 1 times anything is that thing. 1 minus 256 over 1 minus 2. We know 1 times anything is that thing. 1 minus 256 is negative 255. And 1 minus 2 is negative 1. And when I divide, I get positive 255. And that would be what you get when you add up the first 8 terms of that sequence. In other words, a series. That's what you do. Last problem. This one, we're going to use that same form. This time, I'm adding up the numbers for 100 plus 20 plus 4 plus 4/5. And we're going to find s sub 8 again. It's the first term times 1 minus r. Now, 20 divided by 100, that's 2 over 10 or 1/5 to the 8th over 1 minus 1/5. Oops, that should be a big parenthesis. Don't need that little one. So, next step in this process is to do 1/5 to the 8th. All right, that's going to be 390,625. 39066. I gotta fix that. All right. Now this looks very difficult. It's really not. Now, 1 can be written as 396.25 over 396.25. And when you subtract 1 away from that, you get 390,624 over 390,625. And 1 minus 1/5 would be 4/5. Now, one of the big things that we should know from our work with fractions, and everybody should know this, is that if you have a fraction divided by a fraction, I'll just do that, you can say division of fractions is equal to multiplying by the reciprocal for the bottom. So this is equal to 100 times 390,624 over 390,625 times the reciprocal 5/4. All right, so I'm going to do a little bit of reducing here. First thing that's easy for me to reduce is I'm going to reduce the 4 with the 100. 4 goes into 4 once, into 125 times. The next thing I'm going to reduce is I'm going to reduce the 25 with the 390,625 because it ends in 25. So it goes in 1 and 15,625. Now, I'm going to rewrite this just to give myself a little bit of visual space here. So 390,624 over, I'm going to write that in a different color just so that it's easier for me, 15625 and 5 over 1, because I'm going to reduce that 5 and I don't want to bleed the colors through. So 5 goes into 15,625, 1, and it's going to be 3,125. All right. Now I can make this a mixed number, but on my calculator, when I tried to type it all in a fraction, I put this divided by that, or over that, and it wouldn't take the 5 because it filled up the display. So what I did was I divided this by this. It goes into it 124 times, and then I subtracted away the 124, which was the whole number, multiplied it back by this, and that gave me the remainder. Now you could do it by hand or some other way, but the remainder is 3124 out of 3125. Now the book didn't give a nice answer like this. Call it nice. The book said about 125. Well, that's true, but let's call it a day there. And your homework is on the website. I changed it slightly from the original, so please pay attention. Bye-bye.